Hello class, this is a video tutorial on approximating areas under a function. Calculating areas of straight-edged shapes is very simple, as there are formulae for almost all shapes that we know: rectangles, triangles, trapezium, etc. And this understanding can be transferred to areas under a function's graph between a given domain. So if we wanted to find this area here, we can see that this is going to be a triangle. If we wanted to find the area between these two boundaries on this function here, in case you don't know, this is y equals some value k. And even with circular functions or fractions of circles, we can just use the area of a circle and find whatever fraction it is. And now this idea of calculating an area between a function and the x-axis. So between the function and the x-axis in the domain from A to B, so we must always be given some start point and end point, is given the notation the area equals the integral, and by the way, this must always be paired with dx, and I'll get into the notation and the meaning behind it a bit later. So the integral from a to b, so from a to b, of any function that we want. And this is known as, the definite integral. So let's apply our basic understanding of shapes to find the areas of these functions. So let's calculate the following. So we want from 0 to 5 of the function y equals 2, and I've graphed it here. So from 0 to 5, if we just put the boundaries from 0 to 5 like that, we can see from 0 to 5 that has a height of 5, so area equals 5 times, and now the length here, well, if this is y equals 2, so that must mean that this is 2 units up. So 5 times 2, that is 10 unit squared, because this is an area, so it's unit squared. Let's erase all of this. Whoops. Let's just leave that blue one there. So now if we wanted to find it from -2 until 5, so let's just mark it here. So let's say that's -2. And 5 was here again. And we want to find this entire area here. Now we can see that from -2 until 5, that height is going to be 7. So the area is going to be the height 7 times the length of 2 once again, because remember that is the height of 2, so that is 14 unit squared. Now even with shapes such as this, with functions such as this, that is a straight edge, if we wanted to find the area from 1 to 4, so I've marked 1 here already, and let's say 4 is somewhere here. That's 4. We can see that this is an area of a triangle. So the area of this is going to be half the base. Let's say that this is the base. So we need to figure out what that height is. Well, I hope you can see that that height is just f of 4. And by substituting 4 into the function, we get a height of 3. So half the base times the height, so from 1 until 4 is 3 units across. That's half 3 times 3, which is 9 over 2 unit squared. Now if we wanted it from -4 until 4 of the same function, actually we'll just keep that there. So we already have this area. Okay, so we can break this into two shapes. Let's call that area 1, this one here. So area 1 is equal to, well, it's the previous one, 9/2. And we just need to add that area 2. So from -4, so that is -4, until 1. So we want to find this little area there. Well, we can find that by finding first the base, and that length here is f of -4, which is -4 minus 1, so that is going to be -5. So the length of this is, sorry, the area of this is going to be half the base, which is -5, times the length, so from -4 until 5, well, that's 4 plus 1, that's going to be 5 units across. And take a look, this gives us -25 on 5, but now obviously area cannot be negative, so we're just going to take the absolute value of this, giving us area 2 equals positive 25 on 5, which means our total is going to be 9 plus 25, which is 20. Oh no, wait, we can't. That should have been a half, sorry. This gives us 34 on 2, which is 17 unit squared. One last example on this function. Get rid of everything we don't need. There we are. Now we only want it from 2 until 4. So if we mark this in, let's say 2 is about here until 4. And so we want to find that area there. Can you see what sort of shape it is? Well, I hope you can see that it's actually a trapezium that looks kind of like this, where this height here is from 2 until 4. So that's going to be 2 units across. We want this length here. Well, we can see that that point is f of 2, that point here. Since that's f of 2, 2 minus 1, that's going to be 1. And now we have, we need that length there, which we already know to be f of 4. So 4 minus 1 is 3. So that height is 3. Oops, using this shape, we can now find the area that we've outlined here. So the area of this is the area of a trapezium, which is half a plus b times h, which is half 1 plus 3 times 2. Crossing these 2's off gives us 4 unit square. And now for one last example, here we have a semicircle, the function of the semicircles here, and we want it from -5 until 5. So we want this area here. And we can very clearly see that this is a half circle. So the area of this is going to be half pi times r squared, which is half pi times, and now the radius from 0 till 5 is 5. And in exact form, this will give us 25 pi on 2 unit squared. So I hope we can see that we can find the area of some basic functions just using regular area formulas that we know. Hope to see you in the next video. Best of luck.